Hello everyone. This video is intended to help you with multi-part angled projectile problems. We've done multi-part regular projectile problems in the past. This one just happens to be about angled projectile problems, and it also addresses maximum height, which at this point you should know what that means. And this is a two-part problem clearly because a car is driving and then it's flying. You can call the two parts driving, flying if you'd like, or part one, part two, whatever you want. Speed up, fly like a bird. I don't care. What I do care about is that you should not analyze anything dealing with the ramp. I've had people be like, well, since it's 2 meters above the ground and the angle's 28 degrees, the length of the ramp should be this. And then since it's 6 seconds, I have to figure out how many seconds it takes to go up. You're just going crazy. I love that you want to make this as real as possible, but you have some problems. You don't need to do that. It turns out the length over the 6 seconds happens to be exactly 90 meters. You don't do 90 meters, then find the length of the ramp and add that. Do not analyze the ramp. Can't stress that enough. Have I made my point clear? Don't do that. You're crazy if you do. I mean, basically, the most important thing is that you are driving, and at the end of that 6 seconds, you're right here. Who cares about the length of the ramp? Nobody cares. The final velocity from part one is now equal to the initial velocity of part two. And by initial velocity, that doesn't mean velocity in the x. It doesn't mean velocity in the y. It's literally the initial velocity. Look, we are at an angle here. So it is the overall initial velocity. It's not x or y. All right, let's get after this. The general problem-solving strategy is to separate your two parts. I'm going to call this one part one because I'm less creative than you, who will come up something better. Initial velocity. No, I don't want to switch to tablet mode, but thank you. Initial velocity, final velocity, acceleration, distance, and we're going to scroll down a little bit because I'm running out of space, and time. Part two. We are a projectile right now, so let's do our usual shenanigans for this, which involves an XY chart. I'm going to put it over on the side here. I'll put it over on the side. XY chart. Initial velocity in the X, save some space. As you know, this is an angled projectile problem, so I'm going to write VI cosine theta. I'm going to save a little space to do some work there. You don't have to, but I like to. Horizontal distance, time, initial vertical velocity, which is VI sine theta. Notice I'm writing it, even if I don't know what those things are. AY is negative 9.8 because we're still on planet Earth's surface. Change in vertical position and time. Oakley dokley. Notice I have filled, I've set up everything. I've set my table, and now I can go back and start filling in my information. Don't be the number hunter that's like, okay, it's 2 meters. What do I do with that? I don't know. Just get organized. Don't get me wrong. You should know that we're trying to figure out the horizontal distance that it travels, and we are trying to figure out its maximum height. But don't think about how to do that. Set up the problem and do it. It's that simple. So we have an initial velocity of 6 meters per second. We have an acceleration for part one of 3 meters per second squared. And we know that this happens for 6 seconds. This is not the flying time. This is the driving time. Afterwards, we go off a ramp angled at 28 degrees. How nice. And we know that it's 2 meters above the ground. Okay. So if we're trying to figure out how far traveled before reaching the ground, the change in vertical displacement after leaving the ramp will be 2 meters down, hence negative 2 meters. Not much I can do here. All right. Clearly, in the projectile part of the problem, I'm kind of stuck. And in part one, I have 3 knowns. So that's kind of useful. Don't get me wrong. There could be problems where maybe you're solving for the distance traveled in part A, or the first part. If that's the case, and this is a 2-part problem, odds are you can't start with part one. You're going to have to start with part two and work backwards. In this case, we're looking for things in part two, like horizontal distance and maximum height. Therefore, probably going to have to start in part one. Let's get after that. By now, you should know that the most important connection between 2 parts of a problem is that the final velocity of part one is equal to the initial velocity of part two. And I'm going to use math rep number 2 here to figure that out, because that's the only one I can do. So I have the final velocity of part 1 equals initial velocity. Why am I putting that in parentheses? No idea. Plus acceleration times time. And we get a final velocity of, I can do this in my head, actually, 24 meters per second. Want to stress this again. This is not the horizontal velocity. It is not the vertical velocity. The final velocity becomes the initial velocity. So this is the initial velocity. All right, but that helps us because now we can do that the velocity in the x is 24 meters per second cosine of 28 degrees, and we get 21.2 meters per second. And the initial y velocity is, what did I say, 24 meters per second times sine 28 degrees, which gives me a speed of 11.3 meters per second. Yippee. All right. Our goal here is to get the horizontal distance. That is question A. So we need to get the horizontal distance, which means we're going to need the time. By now, you should be experts with this. We're going to be doing a little math rep number 3, which is no parentheses there. What's up with this parentheses today? Delta dy equals initial vertical velocity times time plus 1/2 acceleration times time squared. Negative 2 meters equals 11.3 meters per second times time. That's your initial velocity times time plus 1/2 acceleration times time squared. Clearly, we got a quadratic going on here. I'm going to rewrite it so you can see it. Negative 4.9 meters per second squared delta t squared. There's your a term plus 11.3 meters per second times time. Don't let the units bother you. They're just numbers. Ax squared plus bx plus c, which happens to be 2 meters. If I sub this into the program on my calculator, which you should have put on your calculator, because if you haven't at this point, I don't have to tell you anymore. Like, you got to do it. Or do it by hand and waste a lot of time. Anyway, I get delta t equals 2.47 seconds. There was a negative time, but by now you know not to do that. All right, we are looking for the horizontal distance traveled. That's pretty straightforward. That's going to be math rep number 1. And again, if you're AP, we know that AX is 0. It's okay to use this, or you can use the 1/2 AT squared equation and sub in 0, and you'll end up right back here. So the horizontal distance traveled is simply 21.2 meters per second times the time, which is 2.47 seconds, giving us a distance of, hold on, a little mental math, 52.4 meters. I did that in my head. I swear, I'm that good. And that's about it. I mean, we'll address the maximum height question, but please understand, just really quickly reviewing here, I set up both parts before I even subbed in any numbers. And like, I should have been able to see, like, all right, I have enough information here to get VF, which I could put over here to get VI. And once I get VI, I can get VX and VIY. And then once I get that, I have enough information to get time, which I can bring over here to get delta dx. Like, I could have just seen that because of how organized my work was. You should be there too. All right, and the final question here is maximum height. At this point in your physics game, when you hear that phrase, max height, what is its maximum height above the ground? Or how high will it travel? Those two phrases mean one thing. The final vertical velocity is 0. Okay. If you're trying to calculate that height, which would be, your delta dy, do you know an equation with final velocity and delta d? Because I only know one, not delta t for time. Because if it said time to maximum height, that's a different story. But if we're looking for the actual height, the vertical distance, it's like always math rep number 4. It's always, which is the final vertical velocity squared equals the initial vertical velocity squared plus twice the acceleration times the vertical height. All right. Final vertical velocity is 0. What a joy. So that's 0. Initial vertical velocity was 11.3 meters per second. Don't forget to square plus twice the acceleration, which is negative 9.8 meters per second squared, delta dy. So your final height above the ground is 6.51. Actually, I take it back. I shouldn't have phrased it that way. 6.51 meters is how high you got after leaving the ramp. So scrolling back up here really quick, that means that after leaving the ramp, not drawn to scale, this right here, this distance right there is 6.51 meters. That is not the height above the ground. Again, not drawn to scale. So how do we get the height above the ground? Don't forget to add that 2 meters back. That's the height above the ground. So plus 2 meters, which was the height of the ramp, and you get 8.51 meters. That's basically it. Your multi-part problem and a maximum height question. Let's do a quick review, shall we? All right. First of all, I tried to stress this. List your variables for each part. Seriously, get everything organized before you write down numbers. If you feel more comfortable writing like, okay, I know the initial velocity and putting that on the side first, that's fine, but the number hunters tend to do not as good as people that are very organized and get everything down on paper first, then fill in what they know and create a plan of action. So that's my strong suggestion. It's number 1 here, listed in purple. And of course, the connection between the two parts, as we've seen before, is that the final velocity of part 1 is the initial velocity of part 2. And if it's a projectile problem, I want to stress, this is not Vx or Vy. It is the initial velocity. You're literally at an angle going off a ramp. If the ramp's at an angle, you're not all X or all Y. You're between the two. Also be aware that you could always work backwards, where the initial velocity of part 2 is the final from part 1. I like those problems better for assessments. And then finally, if you hear maximum height or how high and you're solving for that, well, either way, if you hear those two things, final velocity is 0. Final vertical velocity, is 0. If you're solving for that height, odds are it's math rep number 4. If you're solving for the time, it's math rep 2. But that's basically it. I thought this video was absolutely amazing, as per usual with my talents. And I hope you found it helpful if you watched it. If you didn't, you don't even know that this thing exists. And I feel lonely now. Anyway, I'm going to go. I'm going to give this puppy 3 out of 5 stars. I would not change anything about it.